Hello and welcome back to another video. In this problem, we're told that supposes that a function f is continuous on the interval from 0 to 1, except at 0.25, and that f of 0 equals 1 and f of 1 equals 3. Let n equal 2, and we're asked to sketch two possible graphs of f, one showing that f might not satisfy the conclusion of the intermediate value theorem, and one showing that it might still satisfy the conclusion of the intermediate value theorem, even though it doesn't satisfy the hypothesis. So what does this all mean? So the intermediate value theorem states that if a function f is continuous on an interval from a to b, a closed interval, and we let n be any value between f of a and f of b, as long as f of a does not equal f of b. We say, therefore, that there is a x value that is equal to c, right? And it's between a and b, such that if you take f of c, the value is equal to n. So this is basically saying if we have, let's graph this. If we're looking at our function and it's continuous from 0 to 1, so from 0 to 1, we can say if f of 0 equals 1, right? Actually, on the y-axis, we're going to need a little more room, so we're going to have different scales. If f of 0 is equal to 1, and f of 1 is equal to 3, we're saying that if you pick any value in between f of 1 and f of 3, right, so between 1 and 3, then there's some point on the x-axis where the function hits that point. So what does that mean? Well, basically they're saying if you start here and you're getting here with no jumps or gaps or anything, you're going to have to hit every x value on the way, or every y value on the way. And so the problem here is that the function is not continuous on this range. It's not continuous at 0.25, which let's denote here. So what can happen is if the point that the function is approaching at 0.5 is 2, it can skip past it on its way to the other point. This doesn't necessarily mean that it will happen, though, right? And we can say that, okay, we're starting here, we're ending here. We have a discontinuity at 0.25, let's say it's way down here. And then the function continues, and f of x equals 2 still does exist for some value. So this shows that, well, it might still happen, where if you're going from 1 to 3, you're going to hit 2, because there is a hole somewhere, that hole could happen at 2, and therefore you could skip it entirely. So this does not satisfy the conclusion of the IVT. This does, even though the hole means that it was never guaranteed to happen in the first place, which means it doesn't satisfy the hypothesis.